In this video, we're going to look at some of the features of the gradient function. Now, if we look at the graph on the screen here, the dotted line represents the tangent at the point on the graph there. C is just its x coordinate, so up here we can see what the x coordinate is, and this here tells us what the gradient of the tangent is at that point. So as I move C, we see that now it's starting to decrease, but it's still positive. So it's decreasing but positive. So all around here, as you can see, the gradient is positive. Now, at the very top here, if I'm careful, we can see that it's getting less and less. That's about as close as I get to zero. And then as we start coming down the side here now, you can see that the gradient is negative. So all through here, the gradient is negative. Now it's starting to increase again. So at this particular point, we can get it there a bit more. Very hard to sort of so we can see that it's slightly negative there, and at that point there, so right at that particular point there, the gradient is 0, and if I keep moving the point, you can see that it becomes negative again. So by moving the point around there, we can see how the gradient of the function is changing. So here it's negative. At that particular point there, it's 0, negative again. So this actual point here is what we call a stationary point of inflection, because the graph gradient doesn't change sign. It's negative, 0, and then it's negative again. Whereas up here, we have what's called a local maximum, because the gradient, if you watch the value there, is going from a negative to a positive value. So if we look at this quartic function here, we can see that this part of the curve around here, because the tangent line slopes upwards towards the right, it's a positive gradient. And then at the turning point here, at the very top, the gradient is 0, so that's a local maximum. Similarly over here, we have a local maximum, and the gradient at that point is 0. And then down here, the gradient is negative again. So we've got a positive gradient here, and also this part of the curve over here, the gradient's positive, but the gradient is negative here, and also in this region over here. It's a bit clearer on the next page. So the highlighted blue part here shows around here a tangent drawn at the curve at any particular point would have a positive gradient, and similarly around here it's got a positive gradient. Whereas the next part, this part of the curve here, if you draw a tangent to the curve, you see that it's going to have a negative gradient. And finally, at each of the local maximums, that's what we call the turning points or the stationary points, the gradient is 0 at those particular points. So, summarising then, the blue part, which represents a positive gradient, the yellow part here represents a negative gradient, so we've got negative gradient there, this part here. The blue part here again represents a positive gradient. So with this particular graph, a positive gradient means that the function's actually increasing in value. Around here it's getting smaller, increasing in value again, decreasing. So we can see then that the gradient is 0 at each of the points A, B, and C. There, I forgot the blue line, the red line there, not to worry. So we have 0 gradient at points A, B, and C. Now, the gradient's negative between A and B here. So I've written it as A is between A and B. Notice I've simply got the inequalities, not equals, because When it equals A, B, and C, it's 0. So we want to know when it's negative. So it's between A and B, this section here, and also when we're greater than C, this part around here, it's negative again, so x greater than C, which we can represent then as either A comma B and C to infinity. And then finally, we've got positive gradient. The positive gradient is around here. So when x is less than A, and then between B and C, we have positive gradient again. So x less than A, I can write as negative infinity to A, and between B and C. And we can see if this example, the gradient of this graph is always positive, whereas the next one, you can see looking at the tangent line, because it slopes towards the left, it has a negative gradient. So what we're going to do is analyse this graph and have a look at when it has a positive gradient, a negative gradient, and when the gradient is 0. Okay, let's have a look at the first part. Gradient is positive. So if I take the yellow part, we can see that this part around here, the graph has a positive gradient, and also around here it has a positive gradient. So that means we're talking about then, let's just get a pen here. So it's positive for, now we can see that this point here is x equal to negative 1. So the gradient is greater than 0 for x less than negative 1, which I can write as, oh, this is interesting. Text is disappearing. Let's fix this. Okay, so a gradient is positive for x less than negative 1, the yellow part here, and this part around here, the line's gone funny, for x greater than 2. So I can write that as negative infinity, negative 1, and 2 to infinity. Now, the second part, it's negative, so if we take a highlighter, let's get a different color. Let's take orange this time. It's negative around here. Oh, it wasn't orange, was it? Save tools. So this part around here, our graph is, so this time, the gradient's negative, and it's between from negative 1 all the way around to x equal to 2. So we've got, it's between negative 1 to 2, which we can write as negative 1, 2. And then finally, the gradient is 0. The gradient is 0. Let's take a different color again. Let's go red. And it's 0 there and there. So it's 0 when x is equal to negative 1 and 2. So in other words, x equal to, curly brackets, negative 1 and 2. Okay, let's take another example here. Okay, so firstly, let's change the color back here, back to black. The gradient is positive. So the yellow parts of the graph here show when the gradient is positive. So you can see that's between negative 3 up to x equal to 0. So we've got x between -3 to 0 and for x greater than 4, the other part. So that means in interval notation we've got -3, 0 and 4 to infinity. Now the next part, the gradient is negative. So the negative part is shown where I've left it blue. So that is for x less than -3. And when the graph is from 0, x equal to 0, down to x equal to 4 here, the gradient is negative. So that means in interval notation, -infinity to -3 and 0, 4. And then finally, the derivative is 0 when at each of the points at x equal to -3, 0, and again at x equal to -4. So there's the three distinct parts of it. So 0 gradient here, in this particular case, it's what we call a local minimum, local maximum here, and we have a local minimum here as well. So now you should be able to do exercise 4C, questions 1 to 4.